In this lesson, we're looking at two different ways that we can analyze data. The first thing we're looking at today is the stem and leaf plot. The stem and leaf plot is basically a way of organizing a list of data. So it's a way of representing your list without just writing all the numbers in order. So in a stem and leaf diagram, we have the stem, which is a column that contains the first digit of the data points. So this would be the stem, and in here we'd put the first digit of each number. The first digit, so the first digit of the 12 is a 1. The first digit of the 33 is a 3, or 34 is a 3. That's what goes in the stem. Then we have a column for the leaves. The leaf of each column are the second digit of the data points. It'll probably be clearer when I do the example. So for example, here we have a list of data points, a list of numbers that are in order, so that's helpful. And we're going to make our stem and leaf plot using that data. So what we do is we look at each digit individually, and we put the first digit in the stem and the second digit in the leaf. So for example, the first number is 12, so the stem is 1 and the leaf is 2. The next digit is 13. Well, the first digit is also 1, but the second digit is a 3. So I put that in the same row. So essentially what we're doing with here is the stem represents the tens column, and the leaf represents the ones column. That's what we're doing with these digits. If you have different numbers, the stem might represent the hundreds column, and the leaf might represent the tens column, for example. It depends on the numbers you're working with. So let's continue. Where do we leave off? We did the 12, the 13, now we're at the 21. So 21, the first digit is a 2, so we start a new row, and the second digit is a 1. Then we have 27, so 2 and 7. Then 33, so we start a new row for our first digits that are 3, so we have 33, 34, 35, and 37. Then the next number is a 40, so we have 4, I'm just going to continue my line. So we have, and a 0, so that's 140, we have another 40, and then we have 41. So that is my stem and leaf plot for the list of data that I have here. Now, what if I had added a number here? Suppose the first digit was a 5. How would I put the 5 in my stem and leaf plot? So for the 5 to fit into this graph, we need to think about what is in the tens position. Well, the 5 is in the ones position. There's no number in the tens. It's like saying we have the number 0, 5. So we can have a row, for example, I'm going to put this in a different color. We could have a row that starts with 0 and then 5. So that would be for all the numbers that don't have anything in the tens place but are only in the ones place. And then the next thing, the last thing that's missing in my stem and leaf plot is that a stem and leaf plot should contain a legend. So I need to say what these numbers mean. I know that they're in the tens place and the ones place because I have the list of numbers. But if I didn't have the list of numbers, it might not be so obvious. So I need to state the legend. So I would say I take the first number, 1, line 12. That means 12. So you're saying that this is the tens and this is the ones. That's essentially what you're saying. You don't have to add this part. Really, this is the legend. Now, if we look at the diagram we have, how is this useful? Why would we want to do this? What information is this telling us? Well, you might observe a few different things, but the first thing that I observe here is that it's a way of telling us how the numbers are grouped together. So I can tell right away most of my data is in the 30s. But I have some in the 40s. I have the same amount in the 10s, and I have a few in the 20s. So it kind of tells us how spread out our data, where are most of the data points lying in this case. It's also, since the numbers are listed in order, it can help us find the mean, it can help us find, the median, it can help us find the median, and it can help us find the mode. Now we'll look at another example. In this example, we have a list of data that are coming from subjects in a psychological study. They were timed to see how long they could take to do a certain task, and we're asked to put this data in a stem and leaf plot. So the first thing is the numbers were reordered for you, so it's very helpful if the numbers are in order to draw our stem and leaf plot. Now I'll get you started on this and then I'll ask you to finish it yourself. I'll give you a hint. We'll write our key first, or our legend. For our legend, for the first number, we're going to have 5 and 8. This means 5.8. So now in my stem and leaf plot, I'm going to have 5 and 8. Now this stem represents the ones place, and the leaf represents the tenths place, the first decimal place. So it's different from the last one. So this is why the stem is so important, the legend, is so important. If we didn't have the legend, then we might think that this number here represents 58. But because of legend, we know it means 5.8. I'd like you to pause the video here and finish the stem and leaf plot. Now let's look at the next example. Now we can make a stem and leaf plot for when we have two lists of data as well. It's a way of maybe comparing them a little bit. So if I want to put the math and the English in the same stem and leaf plot, I'm going to have a common stem here in the middle, and then here will be the leaves for the English, and here will be the leaves for the math. So for example, I'm going to start with the math. The first number is 9. So that means I'm going to need a stem of 0 and 9. Then the next is 13, so 1 and 3. And then 4 for 14, 15, 16, 16, 17, and then 19. And then I'm going to ask you to finish for the math. But now I'm going to take a different color. I'm going to try the English. So the first number for English is 14. So the stem is 1 and the leaf is 4, 14. Then 16, 17, 18, and 18. I'm going to ask you to finish this and don't forget to write your legend. Now we'll look at how to calculate the mean deviation of a set of data. The mean deviation is basically, it's a measure of spread. It tells you how spread out the data is. And the way it tells you that is it tells you how far away the data points are from the mean. So it tells you it basically finds an average of how far away each number is from the mean. So let's take a look at how we calculate that. Here we're going to do an example. We're given an example of a set of number, and we're asked to calculate the mean deviation. So the first step is to find the mean of this data set. So I'm going to ask you to find the mean, or the average, of these numbers. Pause the video here and please find the mean. So you should have found the mean. You know, you add up all the numbers and divide by how many numbers there are. So if we added them up to 52, divide by 8, gives us 6.5. Then we'll complete the following table. So we'll start by writing in the values that were given in the table. So we're just basically writing our list of numbers here in the table. So our number was 4, 5, 6, 8, 8, 9, 11. Then we write in the mean. Well, we know the mean is 6.5. So we write that in the whole table. We're basically trying to find how far away each point is from the mean. So we're going to subtract the data point from the mean. But so we're finding the deviation from the mean. So we're going to be doing 1 minus 6.5. But we have to do the absolute value of that. The absolute value means we only get positive answers. So even if the answer is negative, we ignore the negative sign and we just write the number value. So the difference between 1 and 6.5 is 5.5. So 1 is 5.5 data away from 6.5, away from the mean. And we do the same for the rest. So the absolute value of 4 minus 6.5. So the difference is 2.5. We keep it the positive number. So if you do 4 minus 6.5 in your calculator, it'll give you a negative number, but we keep it positive. So I'm going to ask you to pause the video here and complete the table. So you should have completed the table and gotten the same numbers that I did here. Check your work to make sure you got it right. The last step to finding the mean deviation is now we're going to take all of these numbers. These are the deviation from the mean, how far away each number is from the mean, and we're going to find the average of this, the mean of this. We're going to find the mean of those numbers. So to find the mean, we add them all up and we divide by how many numbers we have. So we're going to take our 5.5 plus 2.5 plus 1.5, etc. And we're going to divide it all by 8. So pause the video here, please, and finish the calculation. Find the mean of these numbers here that we just found. So you finish by adding up all these numbers, adding up all the deviations we found, dividing by 8, and you should have gotten that the mean deviation is 2.5. So this is our mean deviation. What this means is that each data point, each number in our data, so each one of these, is on average 2.5 units away from the mean of 6.5. So it tells us how spread out our data is. On average, the numbers are 2.5 away from the center. That's what that means. The last thing I'd like you to do is to summarize what this lesson was about. So you're going to answer these 2 questions by following the link to a Google form that I posted on Edmodo. You're going to follow the link, and it's going to lead you to a form where you fill in your answer to these questions. If for whatever reason the Google form isn't working, I want you to at the very least write down your answers to these questions so I can check them in class tomorrow.